What is up, everybody? Today is February 6th, 2025. Another wonderful day of Leetcode. Let's go ahead and see about warming up our fingers for the Leetcode. Alright. Not great. I'm trying to push into the hundreds more, but my finger is just so cold. Alright, let's check out what the problem of the day is. 3160, find the number. Blah, blah. Alright. 3160. Find the number of distinct colors among the balls. You are given an integer limit and a 2D array queries of size n by 2. N times 2. There are limit plus 1 balls with distinct labels in the range of 0 to limit. Initially, all balls are uncolored. For every query in queries that is the form of XY, you mark ball X with the color Y. After each query, you need to find the number of distinct colors among the balls. Return an array result of length n, where result I denotes the number of distinct colors after ith query. Note that when when answering a query, lack of a color will not be considered as color. Let us look at it as an example. So we have 4 for our limit, which means there's going to be, 5 balls from 0 to 4. One. After query 0, ball 1 has color 4. This has color 4. After query 1, ball 1 has color 4, and ball 2 has color 5. Okay. After query 2, ball 1 has color 3. Oh. And ball 2 has color 5. After query 3, ball 1 has color 3. Ball 2 has color 5. And ball 3 has color 4. 1, 2, 2, 3. And we're looking for unique values. It's not considered color if it's 0 has 1, 1 has 2, 2 has 2, 3 has 4, 4 has 5. 1, 2, 2, 3, 4. Okay. This feels sort of like... How big is the value range? Ten to the 9. Ten to the 9 means something sub-ov-in. I kind of want to use a disjoint set in order to do this, because you'd have the color, the label change. You'd use a set as well. It's the sheer range that I'm kind of worried about. Okay, so, but the number doesn't matter, right? The number of them. Unless it's being overwritten. I could use a map and map the colors to the thing. What if I have a count? Right? And say we have, I don't know. We have a count. And then we have a map to whatever the value is. We increase the map. So it's not a frequency, it's just a map from one number to another. Right? And the count is for the labels. But limit is 10 to the 9. What if I had a map? Okay, what if I had a map to count? Map to count. And a map. So it would be label to count. It tells me how many there are. And then the map or the node to label. Right. if the count ever goes below 0, we can delete it. I don't know if this is going to work. Right. And then we say if n to L okay, so if it is not in there, then we're just going to assign this to the label and then label to count right? And if it is in there, oh, we're also going to need a vector and result, and that's going to be for size. Which after the for loop, well, no, after this, it's just going to be result I equals something like this. And then we can do something like, okay, if it is in there, we'll go L2C queries I1 minus minus. If L2C queries I1 0, L2C dot erase I1. Yep. And then to L queries I0 1, and then L2C queries I1 plus plus. Wait, no, hold on. So we're subtracting the label to queries, or label to count, but not this one, right? This is actually going to be node to label. And our node to label, we're going to give it to the node, right? Same thing here. We want to see if that doesn't exist anymore. Label to this, erase, and we want to erase this, right? Otherwise, do that. Oh. It's like a mapping Hold on. 1, 2, 3, 4. Well, that's all right. Hold on. Let's see. Label to count. Node to label. So we want this node, grab its label. Then we want to decrement that label. This is 0. So what's wrong? Yeah. Let's see. This is technically oven, but I'm not sure if this is going to work. Just because of the 10 to the 9, it might be a binary search. I'm not sure if disjoint set would be faster. No, I guess it works. Okay. So it's just a mapping, like a storing of links, basically, to get your information. Yeah. This problem wasn't too bad. Let's see if I can kind of explain what I did, though. So, say we had a query, right? Say we had query 1 to 4, and we have two kinds of maps. Well, when we did 1 to 4, 1 to type 4, right? We want to say that node 1 is of type 4, right? And we can map it using these two. So we're going to say node to label. So into L, we have 1, our node, and it's going to map to 4, right? And then, that's because there's nothing in here, so we can just do that. And then our label to count. So we're going to take the label 4 that we have, and we're going to increment it, right? Now, by keeping the count, we're able to know when we have a number of set unique values. So we're like kind of grouping them together. And so if it goes down to 0, we can just erase it from the map, and we still have our count for all the other things in the map. So in the sense of, like, if we wanted to change type node for 1, right? If we wanted to say 1's now 3, right? The first thing we would do, we would say is our label to count for node 1 is this if we decrement it. So if we say -1 equal to 0, then we can erase the element, right? Which means that there would be nothing left in our map, and our size would become 0. But because when we would then go and replace it, so we would say the label to count for 1, we're going to be basically increasing it, but for the label for 3, not for node 1. We're basically saying what it was originally. So we're saying, because we have the node, right? So we're going to say node to label, right? And our node is 1. So we get the label for 1. That label is 4. So this becomes 4. We know that if we decrement the label to count for 4, that label, we only have one of those 4s that we labeled. Once we've decremented by 1, we know it equals 0, and we can erase the label for 4 because it's 0. We don't want to count it anymore. We can just use .size to keep track of it. And then when we're done, we can increment label to count for 3. And that's it. Anyway, thank you for joining me for this Leetcode problem. I hope you all have a wonderful day. Peace.